So as mentioned in the email this video is attached to, a block is launched from an elevated surface of 33 meters with an acceleration of 12 meters per second squared. Now there's two parts to this question. So part A reads, if the block accelerates over a distance of 41 meters, how fast will the block be going at the end of the elevated surface? And part B is, suppose that the block leaves the elevated surface and lands on the ground 28 meters below the elevated surface. How far from the elevated surface does the block land? Well, the first thing I did was draw a picture to illustrate what was going on in this question, so it's a little bit easier to see. And then from there, I did the initial x position as 0 and the final x position is 41 meters, and the initial velocity is 0, and what is needed to be found is the final velocity. So in order to do that, I use this formula just below, which is the final velocity squared is equal to the initial velocity squared plus 2 times the acceleration times the final x minus the initial x. And then after that, I did the final velocity squared is equal to 0 plus 2 times 12 times 41. And then I got that answer out to be 984. And then to find the final velocity, I square rooted both sides of the equation to get final velocity is equal to 31.37 meters per second. Now again, part B was asking, suppose that the block leaves the elevated surface and lands on the ground 28 meters below. How far from the elevated surface does the block actually land? Well, the first thing that's needed to be done here is find out the forces and everything in the x and the y directions. So the initial x is equal to 0. The initial velocity is equal to 31.37, and the final x is what's unknown. And for that, you can use the formula final x is equal to the initial x plus the initial velocity times time. And then in the y motion, have the initial y is equal to 28, the final y is equal to 0, and the initial velocity is equal to 0. And to find the final y, the formula of initial y minus 1/2 g times the time squared can be used. And then to find the time, the formula is the square root of 2 initial y divided by g, which I plugged my values for and got as 23.43 seconds. And then from there I use the formulas that I had just mentioned. So the final x is equal to the initial x plus the initial velocity times time is equal to initial velocity times the square root of 2 initial in the y divided by g. And then after that, I plugged my values in, and I got that it will land 74.99 meters below the elevated surface.